Yeah, my name is Peter Lanigan. I work for TP Vision in Belgium, and as Owen says, I'm the chair of the CMI group, which looks after the commercial requirements of DVB-I. I'm going to give you a quick introduction to DVB-I and tell you about its current status. And then Paul will give you some more technical details. So first, let's answer the question of what DVB-I is. Well, as probably everybody on the call knows, DVB already has DVB-T for terrestrial, DVB-C for cable, and DVB-S for satellite broadcasting. And DVB-I is a new addition to this suite of specifications, sitting alongside DC and S, where the I stands for Internet. DVB-I delivers services over the Internet to devices with broadband access, and this can be both over the top, over the Internet, but also over managed networks with operator support or operator optimization. The user experience of DVB-I can be similar to DVB-T, C, and S, and all devices with Internet access are in scope. We're not just talking about TVs and set-top boxes here, but also smartphones, tablets, laptops, any device with an Internet connection and a screen. Okay, so why is DVB-I needed? Well, the Internet, of course, has transformed how we access TV. In the last 15 or 20 years, we've gone from having basic video embedded on websites. We've seen this technology used and improved in innovative ways. An early way in which this was used was to provide catch-up TV, with examples like BBC iPlayer, where we saw maybe for the first time real long-form broadcast content being made available to users via the Internet in a new way. This has developed with services like Netflix and Amazon becoming huge global companies, and not just content distributors, but also major original content producers in their own right. We've seen this technology adopted by pay TV operators such as Sky to extend their offerings and to reach new people and new customers. And we've seen whole new types of content and service created, things like YouTube and Facebook Live, which not only bring traditional TV content, but whole new types of content, like user-generated content, channels and YouTube stars and the like for users. So the media landscape has been completely transformed by this, and users have benefited in many different ways. Now, if we think about why DVB-I is needed when all these services already exist and are already widely available, well, all these services are deployed as apps. Now, apps have been a very good way for innovative services to be developed outside the traditional processes of the media industry. They allow effectively a small proprietary client to be run on the user's receiver, whether it's in the form of an application running on an operating system like Android or iOS, or a web page running in a web browser. And they allow a specific user interface to be created for the service and for the service to have its own logic and presentation. Now, this has been a fantastic thing, and it's allowed these services to be created. But it is different to how broadcast TV has tended to work, where we've tended to go through standardization processes of companies working together, and then a receiver can present an integrated list of content from different providers in a consistent way. I don't say one approach or the other is better, but they both have pros and cons, and maybe it's useful with DVB-I to bring some of this structure to the Internet's ecosystem. And apps do have some disadvantages, as we show here. From a user's point of view, content is segregated into independent apps rather than being made available in a consistent program guide, as we have with the broadcast TV. And also broadcast and IP content are separated. If a user wants to find something to watch, they potentially have to go through several apps and program guides to try to find something. And from the user's point of view, not all apps are available on all platforms, and this means that content the user wants to see, or perhaps is already paid for, is not available to them in the way that they want. From the point of view of broadcasters, apps need to be provided and maintained on multiple platforms, which can be a major burden for broadcasters. Especially in the smart TV environment, where there's several different platforms with significant market share. There's also the question of how to get your app noticed in an environment where there are millions of apps available and where the user probably has quite a few installed on their devices. And from manufacturers' point of view, they have to support and certify many apps on their platforms and on their products, which can be a major burden. Across Europe, this is not just a few global VOD providers, but it's also local services in all European countries. So we have to certify dozens of apps for our TVs and for other products. It's hard for us to provide a consistent user experience when a user has to go into different apps to access each service, and each app will work in a different way. And we can't present the integrated content guides that we had before. This also makes it harder for the user to find the content that they want, or to know what content is available. And as a manufacturer, we also end up implementing in our products multiple solutions to the same problem, which brings extra cost and complexity to our products without bringing really any user benefit. So how does DVB-I help to address these issues? Well, DVB-I aims to do for IP services what TCNS do for broadcast. We allow, with DVB-I, services to be signaled and distributed in a standardized manner, so that a specific app is not required for each service. A receiver can present an integrated list of services and content, whether those are just DVB-I services or whether it can also integrate DVB-I and broadcast services in a consistent way. And this means that users can see all the content and services that are available to them, and they don't have to care whether a service arrives via broadcast or IP. Broadcasters can deploy a service once to a wide range of devices, and manufacturers can make a single consistent user experience for DVB-I and for broadcast services. Okay, so I hope that explains where DVB-I comes from and the kind of problems we're trying to solve. I'd now like to give you a quick overview of the commercial requirements we developed for DVB-I. As I'm sure many of you are aware, the DVB process is first to write commercial requirements for a technical standard, and then using those requirements, we develop the technical specification. So by giving you a quick overview of the commercial requirements, I can give you an idea of the kind of things that DVB-I can support. So firstly, in terms of the areas of applicability for DVB-I, we're targeting, as I mentioned, any device with an internet connection and a media player, not just a TV and a set-top box. That device may have a DVB tuner or it may not have a DVB tuner. DVB-I will work over all broadband connections and Wi-Fi, but it will also work over mobile networks. In fact, 4G and 5G are specifically mentioned in the commercial requirements as a means for distributing DVB-I content. DVB-I can work over the top, purely over the top, or it can work with network operator support and optimization. And in fact, a network operator could also use it to deploy their own services. And DVB-I can be received with a standard receiver, able to access all DVB-I services, but it could also be implemented as a downloaded application. Both approaches are possible with DVB-I. So the kinds of service we can support, we can, of course, support broadcast-like services, as you'd expect from DVB, meaning linear TV, free TV, and pay TV. And we can implement all the features you'd expect of a DVB broadcast service, so things like parental control and subtitles, accessibility options like audio description. And you can also have associated applications with a DVB-I service. So you could have a DVB-I service with its own associated HBB-TV application. So you can really recreate the same thing on DVB-I as you can have with TCNS broadcast.
Has joined the meeting.
Sorry, DVB-I also supports some features specifically to IP. So, of course, IP can support things like video on demand. It can offer personalized services. You can have these scheduled.
Has joined the meeting.
Which are made up of a playlist of VOD content items presented as a linear service. And as I said, DVB-I service offerings can be standalone or integrated with the broadcast. In terms of the user experience, well, of course, how a DVB-I service is presented to the user is up to whoever implements the receiver, but it's a requirement that DVB-I can provide a similar user experience to DVB TCNS. So a DVB-I service offering can be presented with a channel list and a program guide, potentially including broadcast and IP services, as you have for other broadcast services. And it's not just a question of the user interface. There's also there's some technical parameters that are relevant here. So we have a requirement that zapping times between DVB-I linear channels are similar to zapping times, channel change times for broadcast services. And finally, there's the issue of service discovery and trust. And this is particularly important on internet services. We have questions here like who provides service lists and how does a DVB-I receiver find services to present to the user. Now, in a broadcast environment, of course, you connect your TV or your set-top box to a satellite dish or a terrestrial antenna or a cable system, and you do a frequency scan, and you simply present to the user the results of that scan. That's not really a feasible approach on the internet, where there may be thousands or tens of thousands or even hundreds of thousands of services available potentially from many different sources. So we've had to find ways to enable a receiver to find services that are relevant to a user. There's also the question of how to identify whether services are legal and trusted. Anyone can take the DVB-I spec and make services available in a consistent way. But of course, if we're trying to create something, enable the creation of something similar to broadcast TV, users will expect services to meet certain standards for legality and things like regulatory requirements like child protection and so on. Now, this is not just a technical problem, but also a commercial and legal problem. It's not about limiting who can use DVB-I or the kinds of services you can deploy. In the end, anyone can take the spec. But we've created mechanisms which firstly will allow a receiver to find relevant service lists by querying a registry with certain parameters, for example, geographical location or user interest, and find lists of services that are relevant to that user. But a receiver can also verify the source of a list. So they can check whether it comes from a trusted source and know whether it's then likely to comply with local regulations and standards and so on. The DVB-I is not limited to being deployed in that way, but we provide the hooks and the technical facilities to implement a trusted system like that. Okay, so that's a quick overview of the commercial requirements and the kind of services and things you can do with DVB-I. Let's have a quick look at what we mean when we talk about the DVB-I specifications. If you go to the DVB website and you click on the DVB-I link, it will take you to the first spec in this list, which is the DVB-I Service Discovery and Program Metadata spec. And this was published last month. It's available freely at the URL there. And this covers indeed the service discovery and the signaling of DVB-I services. But DVB-I builds on some other DVB specs as well. In particular, it builds on the DVB-Dash spec. This is a profile of MPEG-Dash, which is used primarily for delivering audio and video services over the internet. This was updated this year to improve low latency support. So low latency means the latency with which you can deliver a service. This is important for broadcast services and particularly for live services. So there's an update to that was published in June with low latency support. And in fact, there was a small update to that in October as well. You can find it at the URL shown there. And a forthcoming spec, which is very important, is the DVB Adaptive Bitrate Multicast specification. Publication of this is expected in Q1 of next year. And this will allow a network operator to optimize how linear TV channels are carried over their network, so that rather than carrying each service once per user, once per consumer of the service, they can simply carry the service once using multicast technology. And this can be done in a way, in fact, which is transparent to the end device. And of course, all of this builds on the other specifications DVB has, particularly the DVB video and audio coding formats spec. And this provides the audio and video formats to enable services, everything from standard definition through high definition to full UHD with high dynamic range and high frame rate, and also next generation audio. Now, in the past, DVB would kind of stop here. Once the specifications are available, it will be up to the industry to take these and make use of them. But with DVB-I, we're trying to go a bit further. And in fact, this is setting the stage for how DVB is going to work in the future. We're going to try to do more to help the industry adopt DVB-I technology. Our aims here are to accelerate and assist with deploying DVB-I. We want to help service providers, for example, to create interoperable services and to help manufacturers to create interoperable clients. We want to do more to verify the specification is correct before people start deploying it. And we want to create a framework for further experimentation and development. And in more concrete terms, what that means is shown in this slide. DVB issued an RFP a couple of months ago for a project to cover the creation of example service lists and content guide metadata. These can be used. These will be usable by manufacturers and developers of receivers to verify that their implementations are correct, and they can also be used as templates by service providers for their own services and deployments. Similarly, we're creating some example low latency dash streams. These can also be used for verification and as examples. And we're creating an example DVB-I client implementation in HTML5 and JavaScript. This will implement service discovery, service selection, content guide, and content playback. And this will help to verify the specification is correct and may actually be a useful first step for real client implementations. The RFP was issued a couple of months ago. It closed, I think it was last month, and supplier selection is now in progress. We aim to show the first results of the client implementation at DVB World next year, so that's in March. And then at IBC next year, we'll show the full results of this project should be available. DVB is also working with the Dash Industry Forum to extend FFmpeg, which is an open source audio-video encoder, to support low latency Dash. This is also in progress. In fact, I think a first beta version of the software is already available, and this should be available fairly soon. And we also expect this to help a lot with deployments and testing. Some of you will have been at IBC this year. There was a demonstration of DVB-I, which is shown here in the picture. This included a demonstration of DVB-I hybrid service list, so of showing an integrated service list with broadcast services and IP services. We showed DVB-Dash low latency streaming, and we showed multicast adaptive bitrate. And the receivers, which you can see in the picture here, are an implementation on a television, both a native implementation and an implementation of a DVB-I receiver in an HDTV app. We also showed, which is another possibility for deploying DVB-I, we also showed DVB-I services being received on tablets and smartphones. There was a lot of interest in the demonstrations we had at IBC, and I think a lot of interest was also demonstrated by the fact we had 12 companies contributing to these demos, which you can see listed there. In terms of future activities, well, apart from the testing and the verification and validation work, of course, DVB standards have been evolving for more than two decades, and DVB-I is also not going to stand still. We're going to, of course, maintain the spec, and I think the spec will also be extended with the new features. And of course, in the end, this is going to be driven by DVB's members. It's worth noting DVB-I is also relevant beyond DVB traditional membership because it can be used over any IP network. It opens up many possibilities for how deployment possibilities for DVB-I. One particularly interesting one is that it's going to be possible to use DVB-I with 5G networks. That should already be possible with the spec as it is today, but I do expect some work in the next year or so where we're going to look at making sure DVB-I can support all deployment options and all kinds of services over 5G. And I think this will be an important link from the broadcast world and the mobile world to work together more. And perhaps we can collaborate and generate a lot of business opportunities for working together with DVB-I. Okay, finally, just a few conclusions before I hand over to Paul. DVB-I enables the delivery of DVB services over the internet. Services can reach more users on more devices and can reach users without access to traditional broadcast reception. Users will be able to access more services. And they won't need to know or care whether a service reaches them via DVB, TCS, or DVB-I. And DVB-I will continue to support its members with new deployment options. DVB-I will bring opportunities to support new parts of the industry, and it extends DVB's relevance outside the traditional broadcast domain. Okay, thank you. I believe, Owen, that I will take any questions now.
Great, Peter. Thank you very much for that. We'll ask Paul to get himself ready at the other side. If you could just leave your conclusions up there for the moment, Peter. We do indeed have a few questions that have come into us. You may wish to defer to, because Paul may cover some aspects of these answers, but let's put the questions to you in any case, Peter, and we'll see what we come up with. Ronald has asked, given the move towards all IP, do you foresee in the long term that DVB-I will replace the other DVB transmission technologies in the future? I suppose DVB-I is not really a transmission technology itself, is it?
No, I mean, it's more an enabler for distributing DVB services over the internet rather than a transmission technology itself. I mean, whether it will replace broadcast services, well, that's not for me to say. I mean, it's another way for DVB services to be distributed. But in the end, I guess the markets and maybe also regulators will decide whether it's, to what extent it replaces broadcast services. DVB-I is intended to be deployable alongside a broadcast. So it's not specifically aimed at replacing broadcast. It's an alternative way to reach your users.
Indeed. Let me just see, there's something coming through here. I have more questions coming through on the chat, but I'll just keep working through the Q&A here. Sven is asking a question about ABR. So this is multicast ABR, I guess. Why is ABR not coming together with video and audio encoding integration, which seems to be already available, if I have understood it correctly?
Well, the multicast ABR spec will it's simply taken a little bit longer to be developed. It is close to being complete, and it will be published. It will be published early next year. If I understood the question correctly, it was about why when the spec will be available. Is that correct?
Yes, I guess why yeah, yes, exactly.
Some pieces of work take a little longer than other pieces of work. I think that's the reason. Indeed.
Sharad is asking, how do you go about verifying the authenticity or legal status of the content or service provider? That's his first question. And a corollary to that, does it mean that DVB-I will work as a gatekeeper?
That's a very good question. Well, first, DVB-I will not be a gatekeeper. Anyone can take the DVB-I spec and use them. And we also can't solve this problem entirely ourselves. What we provide a means for a receiver to verify where a service list comes from, and then it will be up to. It's going to be up. Well, some further work will be needed for someone to build an infrastructure to allow to make use of this technology. So a receiver, so that there'll be a way for a service list to actually show that it comes from a regulated source. So I mean, I think this is rather similar to the way TLS works on and HTTPS work on the internet today. They allow you to verify the source of a website. We can use the technology to do a similar thing to allow you to verify where a service list comes from. But I would say this is an area, although I think the technical pieces are in place to do this, exactly how it's used by the industry to achieve this is still going to require some discussion, and maybe individual deployments will use it in a different way, or in different ways. Indeed. So that's not a very precise answer, but it's this is still an area where I think with the industry we have to, and also as regulators, we still have to give some thought.
Indeed, and I think at DVB World in Valencia in March, this is one of the topics that is sure to generate quite a bit of discussion. A few more questions we'll just run through quickly here. How do you see DVB-I working with Apple devices? Unencrypted dash runs on iPads, but will it support HLS for Apple TV and iPhone?
Maybe Paul can answer that question better than me. I'm not sure the technical spec specifically mentions HLS, but it will be very easy to extend it to use HLS as well. Maybe Paul can answer that question better than me, though.
Yeah, so we don't, obviously DVB spent a lot of time working on an interoperable profile of Dash, and we have that now, as Peter's spoken about, as A168. It's possible to indicate an HLS manifest in the DVB-I service information, so that if a player understands what an HLS manifest is, it could then go and retrieve that. But we don't make any specific statements on the payload formats or anything else around HLS.
Okay, so Sharad has come back in response to the previous question, just to say, does it mean that this aspect has not yet been fully developed or thought about? I think, Sharad, the answer there is that really it's not DVB's place to make decisions on these regulatory aspects. That is something that the market and the regulators in the individual markets need to decide. DVB creates technical specifications. So it's not that we haven't thought about it. It has been discussed and thought about, but it's not really DVB's role to solve that problem. We have a question from Sven Reuter here. What about login options for pay TV services on DVB-C, for example, and also IP services? What about storing the login access data in the TV? Peter?
Yeah, that's also a good question. I think there's various ways this can be solved. An obvious one is to make use of an HBB TV application for login. I don't know if Paul has any other things to say about that, but there are ways to do that using, for example, an HBB TV app.
Yeah, so we have, obviously there's the ability, when we need to get user information, we need to signal some sort of application or some sort of content gathering dialogue with the user. We do have the possibility to signal different applications inside the DVB-I service list. I think I will show some of that in my examples I have coming up, but that's certainly the preferred option. Storing the credentials and everything else in the device, I think that's obviously something that's it's a bit of a double-edged sword. Part of the credentials and part of the access tokens could be stored in the device, but obviously there needs to be some sort of server side or service provider side interaction as well that goes along with that.
Thanks, Paul. We have a lot of questions rushing in here. I'm inclined to move on to the next part of the webinar with you, Paul, because I think it will answer some of these questions. I do want to just touch on one point. Elfed has raised the very valid question as to how companies, both members and non-members, can get involved in launching activities and in the pilot and so on. I mean, we know that we will have a reference application, reference client in time for DVB World in Valencia, and we'll be announcing a supplier for that very soon, I believe. And so in the framework of that activity, we hope to be able to invite content providers to do the necessary wrapping on their services in terms of DVB-I metadata and make those services available to a DVB-I reference client. I don't know if Paul or Peter, you want to add something to that.
Yeah, no, I think that covers it pretty well, Owen. One aspect is, of course, DVB is doing a lot of this work now amongst its members, but with the reference client and some of the work we want to do in the future, we do have a potential to open source and community source or community development some of that material as well. So there'll be opportunities for those people who don't necessarily want to contribute heavily into the specification development to take a role in moving this technology forward in the industry.
Yes. Okay, Paul, I'm going to hand the presentation rights across to you, and you can take us forward. I'd like to say thanks to Peter Lanigan. Stay with us, Peter. We may need to come back to you for some of the questions later on. Paul, it's over to you.
Okay, good. So I'm going to talk a little bit about some of the technical aspects. Peter's given you a good overview as to why we've been doing DVB-I. He's touched a little bit on what some of the capabilities are, and I might repeat some of those things, but I'm going to do mine in a slightly different style, and I'll be using a few examples from some of the aspects that we cover. As soon as I figure out. Okay, so if we take a look at what DVB-I is, and if you look in the specification, Blue Book A177, you'll see this diagram here on the left. And I've kind of annotated it down to break it down and highlight 4 different areas which DVB-I as a project is covering. One of the first aspects, and some people have already asked this, is service list discovery. How does a receiver, be it a television set or a mobile phone with this capability, actually go out there and find these service lists that it needs to go and interrogate and get lists of channels and everything else? The discovery aspect is one part. The service lists themselves, what does it mean to have a service list available on the internet, and what's the format of that, and what information does that carry? The third aspect then is the content metadata, and of course, having television programming without metadata and without an EPG is a little bit last year or last decade, so we have a good section on that as well in our specifications. Then of course we talk about media representations, and a lot of that work has already been done in the DVB-I specification, but we will show in the DVB-I then how traditional broadcast services, some of the DVB IPTV work, legacy work can be integrated, and also how some of the SAT IP technology can be integrated into a service offering. So to do this, we have a bit of a high-level information model, if you like. At the highest possible level, we have a concept we call the service list registry. And this is really one or more known points on the internet which provide service lists or point you to multiple service lists. A service list registry could be operated by a national organization, it could be operated by a broadcaster, it could be operated by a regulating entity, or just someone who wants to offer a vertical IP television service. These service list registries then, once they've been queried, the device can then go off and interrogate the service lists and the services that are described in that registry. For each service, we then have different aspects. We have service instances, which we use to project different information about the types of delivery mechanisms, whether it's a traditional broadcast service or an IP broadcast service. And we also have event information, so that'd be all the programming, the program information for the channel change banners, the full EPG, and everything else. So when we look at these things, then we've really spent a lot of time making sure that we do things in an internet-centric manner. So service list discovery then uses HTTP to go and look to interrogate the service list registries. And you can structure queries in certain ways. So we've looked at the use cases that were brought in through the CMI activity and the commercial requirements development to identify what needs to be requested from the internet. From there on in, there's a lot of services which are delivered, and along with those, each service, then we have the ability to request metadata, programming metadata, based on various ways which are similar or analogous to what might be done today with an EPG. So service list discovery, at the very highest level, we have this request. We can structure the request in a way that we can ask for service lists which are targeted towards a specific country. We could ask the registry for service lists which target a specific language, a genre, those that may be provided by a particular entity, which could be a regulator, and some of those which could be identified as being formal regulated lists for an organization. When we look at the service list discovery, and you'll see some of these examples in the specification itself, we have the ability, I just have to move something on my screen here, to then signal as a regulator flag. Entities, service list registries can be signaled as a regulator, or just, which would be a national organization, or as an ad hoc distributor of service lists. Okay, so within each service list registry, then we have providers, and a provider has some contact information, and there, so we and each provider of service lists could actually offer multiple service lists within their domain. Each service list then has a URI to an XML document, which is really the crux of the list of television services that they're offering. In addition, we support multi-languages, and we've made it possible to make the service list available in multiple demographics. A lot of these elements you see here are actually optional. So if they're not specified, then the scope of the services being offered is much wider. The service list URL then, or URI in this case, points us to the XML document that you could go and retrieve, and it has all the details about the services, the service instances, and the program metadata. As I said before, service lists can be targeted to different languages. If this element specified, for example, when you ask for service lists which are German, in the German language, you would only get the responses back which match the language specified here. And of course, because we know that some services are only really intended to be in certain demographic markets, we can target at a country level as well. Okay, so the service list then has lots of different aspects as well. We define geographic regions within the service list, rather than just assuming that everything aligns with countries or counties or cities. We make it possible for each service list provider to define their own geographic regions, which could be at those levels, or they could define other categories as well. We've primarily used postal codes and GPS coordinate systems to allow the service list provider to create their own definitions of geographic regions. For each of those regions, we can then create an LCN table, a logical channel number table, for some reasons I'll show you coming up. But we also then have all the parameters for the different delivery mechanisms. We want to make sure that if a service is delivered by a traditional broadcast mechanism, DVB-T, S, or C, that we can understand that there is an IP equivalent of that available elsewhere, and make sure we can do some service correlation. We have the ability to, in the service list, to signal, as I was hinting at before, some interactive applications, and we have different mechanisms and different launching approaches for those. In addition, we can signal what we call out-of-service banners, because there will be times when services are not available, accidentally or deliberately not available. We have the ability to indicate services which are only available at certain periods of time. This could be because it's an event-based service, a linear television channel that may only exist for something like the Olympic Games. It could be a service which only comes on at certain hours of the day or certain days of the week. And it could be used to do some interesting service interworking. We'll show an example of that as well. For each service, then, we have the ability to indicate different content guide metadata, program metadata, that can be used to construct content guides. If we take a look inside a service list document, and this is one I think that was put together by some of our colleagues at SES, this shows then how the region structure gets created. We have the ability to specify regions without any sort of location control. In this case, these regions would be something which could be used in a dialogue with the user to understand which region they may be in. Here we can see some examples where we use postcodes as well. I don't think I have an example of GPS coordinates, but it means that the same approach would apply, that for any particular region, we can say that these circles defined by latitude, longitude, and radius compose a geographic region. When we look at the LCN table then, I've got a few examples of it here. We can then say that for each different region, each target region, we can define our own LCN table. So we see some examples here of radio and television services being integrated into a single channel list. In this case, the provider has denoted the radio services at channels starting with 1000 and regular television channels starting at 100. But again, that's just their own personal preference for how they want to prioritize and order their services. Because we have these regionalized logical channel number tables, we can define different services for different regions using the same channel number. So here we see channel number 167 being used for local channels in Bonn and Aachen, depending on which channel number table you have active. When we look at the service itself then, and this is a little bit of a cut down version. If you do a lot of work with XML, you realize that XML documents get very long very quickly and don't look very good on screen. So I've cut it back a little bit just to show you the significant points here. But this is an example of a DVB-I service definition. We start at the top with an identifier, and you would have seen that previously in the logical channel number table. So this is how we link from the channel number table down to the service definition itself. This service here that we're looking at only has a set of audio attributes. So we've tried to use a bit more of a knowledge-centric model and say that, and leave it to the device then to determine that if there is only audio attributes on a service, then it's a radio service. So we don't use a lot of signaling that we might have done in the past to say this is just a radio service or a data service. We let the device make that determination based on metadata provided. Within this service, the satellite radio service, we have it's defined as a DVB-S delivery mechanism. So we can see here some of the traditional triplet information and some satellite positioning information for RNE Radio 1. This is the information then that can be used to make sure we can align the delivery of over satellite with what could be a delivery over IP. In this case, the DVB-S service is augmented with a SAT IP retransmission on a local network. And so this query parameter would be something given to the local SAT IP gateway in order to tune in onto the IP service. There's some other characteristics we can define in here, and I don't show these here right now. We'll learn more about those in Valencia as to how the terminal can differentiate if it does have a DVB-S receiver and it does have a SAT IP tuning capability, when and how it should adapt to the different signaling interfaces. So I talked before what we call time slots or availability windows. In this case, we look at a service instance which is available for a couple of months of the year, July and September by the looks of it. So this service with its only single service instance would be available through these 2 months only. If someone tried to select the service outside of this period, well, in this case, for this example, that would be an undetermined behavior, and the device itself would need to provide some information to the user. Otherwise, we could also signal in here an out-of-service application or an out-of-service logo screen to be presented outside these normal transmission hours. This is, again, the mechanism that we use, primarily the mechanism we use to signal event-based services. So then, with the previous examples all showed a single service instance, and that's very useful. We want to make sure that DVB-I carries forward the legacy that we have with DVB-C, S, and T. Here we see another instance where we have another service instance where we have two delivery instances themselves. One would be the service in high definition, that's the highest priority service, and one would be that same service in standard definition. In this case, the receiver then would look at this metadata and determine if it could receive on the high definition service. And if it could, then it would obviously do so. If it couldn't, then it could fall back to the standard definition service. Within any service, though, because we're allowed to carry multiple program ID PIDs and multiple elementary streams, we have the ability to signal different content within that same service. So this one has an AC3, and I forget the other one, but here we can see that this service has two audio services signaled. Again, this can be useful when you're targeting multiple device types. One device, maybe a television set, would support one of these audio coding systems, and another device, perhaps a mobile phone or a tablet, would support the other one. In this case, then, we don't have to define different services or different instances of services which are applicable to different device classes. And then, of course, we can add a third service instance, and this would be a DVB- service instance in this case. This would be the IP version of das Erste, and that then shows where the URI is to retrieve the manifest for that service. Within here, we've set this one as a service priority 3. This might mean that if a user's device, a television set with a hybrid television set with a DVB-S tuner and an IP receiver was tuned to stick to the service, and for some reason it was cloudy. We get that a lot where I live. The satellite signal dropped away. The receiver itself would just drop to this service instance 3 and start taking the service from IP network. Could also do it the other way around. We could set the dash service as being priority 1, so that would be the first choice for the receiver. In the instance that, in the opportunity when there was a disruption to the IP network, either through a breakdown completely, or you might fall below one of the lowest adaptation set levels in the manifest, then the receiver could switch across to a different service instance. And that's a blank screen. Okay, so if we take a look at content metadata then, we learned a lot from the work that the BBC and some others have been doing with Freeview Play. And they've been quite successful in defining a content metadata regime and an interface towards it. So we've defined a series of REST APIs that can be used to interrogate content metadata services, which are normally stood up by the same entity that's standing up the linear television service. We have the ability to request summary program information that can be used for a channel change banner. And we can also request full program information to obtain all the details around a specific event. The data mechanism we use TV Anytime as the response format, but we've kind of profiled that down a bit to just contain the functionality we need to meet the commercial requirements. Logically, we define that the content metadata service should be able to provide plus or minus 4 weeks of content, program information content. And so, yeah, I don't think there's really a restriction in there from a technical perspective, but at least we have the ability to see that. Again, we find that more and more people who are used to an internet-centric model for information and services and news and things, this is kind of a window they feel more relevant with than just most places where there's a 7-day window. We have the ability to ask the network for categories and series information. We have the ability to do some service aggregation and some metadata aggregation in the network. And we have the ability for the network server then to construct graphic elements that sort of align with the scheme used in the UI, where black and white, one-to-one, different aspect ratios, etc. The whole idea behind this is that we're sort of trying to offload the burden of content metadata management into the cloud or the edge network. We know that television receivers these days are more and more capable, but the more we can offload into the network, we still believe makes for a much more useful service experience. If we look then, we can see some examples, a few examples I've put here of information that we put into the metadata scheme. And these are some areas we've extended TV Anytime. This is a list then of some of the information we give for the service, and we can see here that a logo for the content guide provider could be given. There are instances where the broadcaster themselves or the linear channel provider hands that the responsibility for the program metadata off to another entity. Within here, for each service, and we can specify different endpoints. So we define a schedule endpoint, and this is where the terminal would make an inquiry to determine the summary program information. We have what we call the program info endpoint, which is the more detailed information, and that can be queried by the terminal. And we have a group information endpoint, where you can find more information about programming in specific categories. And you can even request that endpoint to tell you what categories of information it's got. There is another endpoint type. I don't have it in my example, and it's very closely related to how the group info endpoint works in determining programming that's in a series. So by way of example then, this would be an HTTP or HTTPS request that's issued by the DVB-I client. Here, where it's requesting a 6-hour block of programming on the afternoon of June the 6th, 2015. It's saying it wants to have it from the service ID, which is known as das Erste, which we saw before. And it's asking that the server, in its response, just include the URLs for graphic elements, which could be posters or images of actors and everything else in 16:9 ratio color format. These image variants can be constructed in different ways. We have a number of those defined. And again, the server then would take action to ensure that success. If it could put a URL in the response to an image format, an image which is not defined, but that URL would then contain necessary processing instructions for the image to be constructed dynamically. Then we can also use the same schedule info endpoint to ask about what's happening right now. So when we tune to a service or connect to a service, I'm not quite sure what to use when we talk about IP, We know that we've connected to Das Erste, and that's the channel that we're currently watching. We can inquire against the schedule info endpoint then a now next flag, and that will give us at least two programs back in the response. The current program that's currently on air right now at the time the request was received, and the program which is coming up next. If we want to have all the details about a specific program, we do that with the program info endpoint, and it's a much more simplified request. We can put in a single program identifier here, or we could actually, I believe you could probably ask for several program identifiers on this endpoint. For each one of those program IDs that's specified, you'll get back all the programming information that's known about it. Again, that list is sort of a profile of what TV Anytime would use in its program info data type. We continue to use the CRID structure, which is used by TV Anytime as a unique identifier for each program. These seem to work quite flexibly and reliably in a content metadata system. So just a few other notes then that I didn't cover directly today, but we'll talk about in Valencia and other places. We can signal service lists through a transport stream, a broadcast transport stream in the NIT or the BAT. So we can help support a hybrid delivery model. We have the ability to use DVB- and low latency extensions that's just recently been published. And as Peter mentioned, we were demonstrating that at IBC back in September. And we're working a lot in DVB on this multicast ABR specification to ensure we can deliver this segmented content reliably and optimally across a network. Obviously something that unicast doesn't scale particularly as well as broadcast historically. So with DVB-MABR, we should at least be able to solve a large part of that problem.
Thank you, Paul. I'll just ask you to leave your notes on the screen there for a moment. We have about 6 minutes left of this webinar, and the challenge I have for you and for Peter is to see if we can get through all of these questions. So
okay,
let's try and keep the answers brief. Gordon is asking, what TV devices are available for development now? We have a demo app and a framework running on tablets and browsers, but we want to move to TV.
Well, I think, Peter, I don't know if you can answer that one better, but I would say whatever TV supports your application framework. Without knowing your application framework, it's hard to say what that is. But
yeah, just to say, I agree with what Paul said. I mean, I was involved with the demonstration at IBC, where my company supplied Android TVs. We'd implemented a DVB-I receiver on an Android TV, so that's one option.
And certainly we had HPV TV clients HPV TV based clients working at IBC as well. Is DVB-I aiming towards on-demand content as well?
Well, yes, part of what we have in the box sets query, and again, only now we don't talk about too much, but is the ability to link to other episodes of programming. We can deep link those, and the deep links can reference stored content. So it's possible to do that as well. At the moment, we don't look at DVB-I as a VOD library at the highest level, just because there are so many of those, and there's quite a few nuances in there. That might be something that the commercial group starts to look at when we start seeing more and more adoption of this technology.
Okay, is DVB-I somehow similar to ATSC 3.0?
I think in some ways yes, in some ways no. DVB-I is a service definition layer and a content delivery layer for IP transport. I know those are some aspects that ATSC offers, but that's more of, they also have a different construct in delivering IP over a broadcast mechanism as well.
Yeah, we touched on this earlier with the question about Apple devices, but just slightly different phrasing. Would DVB-I be compatible with CMAF to transmit to Dash/HLS and therefore make it compatible with all devices?
Yes, I mean the DVB-I 168 specification uses CMAF chunks. to deliver in a low latency format. So I don't see why not. I'm sure, at least to my understanding, that there's not a lot of difference in the media format there. That's why it's common. So it's really just the manifest format, which varies between Dash and HLS.
Question from Eric here. Is DVB-I workable as it is today over unidirectional IP broadcast transport? He gives the example of OTT over satellite, or will it need additional specifications?
I don't think we've really taken a look at unicast, unidirectional broadcast. We've really looked at this as how do we bring television into the internet era, and so obviously a large part of the internet is bidirectional communications. Large parts of the multicast work are obviously unidirectional. The multicast aspect is a unidirectional function, but requires some bidirectionality with devices on each end of the multicast.
Good. We have this question a lot around IBC. How does DVB-I fit together with HBB TV?
And it's a good question. So certainly DVB-I, and I hope what you've seen from what I've presented today is a way of announcing internet delivered services and how those services can be aligned with broadcast delivered services. We see a lot of people wanting to just stand up internet television channels and finding and making the best use of those in hybrid or IP-only receivers is difficult. So in that respect, there's no conflict with HBB TV. DVB-I, we have the ability to signal HBB TV applications in the same way as they can be signaled through a broadcast channel today. So again, that helps with the application model for IP delivered services. I don't believe that there's really any conflict or contradiction between HBB TV and DVB-I. I think they support each other very, very well.
Good. Quickly, last couple of questions. Sharad is asking about audio codecs. Are these MPEG-H, AC3? I mean, I think they're whatever audio codecs are defined in TS 101154, which is all of the above. That's the right answer, Owen. Thank you. I'm a fast learner. And we have, so the TS 101154 is DVB's audio and video coding specification, and it should have all of the answers there. Does DVB-I support recordings the same as DVB-SS2T or T2 transmissions?
Again, in an internet-centric model, the whole concept of recording may be a bit different. So we do include some flags and some other controls to allow or restrict the recording of content. Ideally, you know, in the internet model, when a DVB-I service is presented, it's file-based, it's stream-based, it's stored in the network somewhere and made available for future use. So we don't really see that the recording, local recording is necessary as having an offline copy available. I don't believe there would be anything that would stop a device from recording content which is delivered using IP, except for the DRM requirements.
Good. I see two more questions. For those who do need to drop off now, just to say that we will have a recording of this webinar available as soon as possible via the DVB website, dvb.org/webinars. It may take a day or two just for us to get that up onto YouTube. But immediately afterwards, I will make the slide deck available. So just give me a few minutes after this, and we'll get the slides up there. So a final couple of questions: is authentication between the DVB-I client and the DVB-I servers needed or required?
It's not needed nor required, but it can be. We can use some level of authentication if so required by the service provider to grant entitlements. Okay, and the final question for today from Christian, who says, "Hi Paul, will there be a possibility for different priority for video and audio? For example, if there are copyright restrictions for language versions?" that's a good commercial requirement for Peter Lanigan to put. We don't have the ability to do that at the moment. We haven't really treated those differently, but it's an interesting use case. So I don't see why it's not something that could be added. Again, most of what we've done in the service layer is to help the device identify the streams. And if there was some prioritization to be done, indicating that would be quite straightforward. Of course, with any metadata scheme, how much the end application makes use of it is really at the discretion of the device, the application itself. So that needs to be looked at.
Yeah, just to say, if people have interesting new commercial requirements, I think that's something we will be collecting in CMI next year. So I'd really encourage people who have new requirements to bring them forward.
Great, and you will find contact details for both Peter Lanigan and Paul Higgs on the DVB website. If you browse through to the home pages for their respective working groups, CMI and TMIPI. I want to thank Peter and Paul both for preparing and presenting the webinar today. To thank everybody who joined us online. We were just short of 70 participants throughout most of the webinar, so that's quite a bit higher than some of our other webinars that we've had in the past. So that's really indicating the level of interest that there is in this topic. And finally, to say again that DVB World will certainly have a big focus on DVB-I. It's in March in Valencia in Spain. There is a pre-conference masterclass with presenters from Unified Streaming, from TP Vision, and from Sophia Digital on deploying DVB-I services. And I am pretty certain that masterclass is going to sell out. The interest levels are very high in it. We're not sure of what our maximum number is for that yet, but we'll be finding that out soon. And so if you really want to come and to attend that pre-conference masterclass, I recommend that you register for DVB World at dvbworld.org as soon as possible. So thank you for joining us, and we hope to have another webinar in February on the topic of dynamic HDR mapping, but you'll find more info on that on the DVB website in due course. Thank you.